So in question 29, we're given two recursively defined sequences. Remember, a recursive definition of a sequence always consists of two things. We need to be told what the first term is, or a particular term in the sequence, and we also need to be told how to get to other terms. So this says the next term is the current term minus 3. So this is decreasing by 3 each time. So it says for each recursively defined sequence below, write the first few terms, and then it says, and then use the terms to write an explicit equation. So we're going to come up with the explicit equation giving these recursive definitions. So let's do A right here. So if we're looking at A, you can see we're starting at 17, and then each time it says, if you read it, it says the next term rather is 3 less than the current term. So I'm just going to take the 17 and decrease it by 3 and I'll get 14, and subtract 3 I'll be at 11, subtract 3 I'm at 8, subtract 3 I'm at 5, etc. So that's basically what the sequence looks like. If I want to write the explicit rule for it, you remember we need to know the zero term. So the zero term, right, is the term that occurs before the first term. My first term is 17, and to move forward in this sequence, I'm subtracting 3 each time. So if I want to go back and get the 0th term, I'm just going to add 3. 17 plus 3 would give me the 20. So here's my 0 term. And now that I know the 0 term, I can write the explicit sequence. It's pretty straightforward, right? It's just t of n, the value at any spot in the sequence is let's see, negative 3 times n plus the 0 term, plus 20. So now I can verify that this is working correctly. So for example, if I look at this, this is the first term in the sequence. If I put that in for n, negative 3 times 1 is negative 3. And then negative 3 plus 20 is 17. So you can see it correctly identified the value of the sequence when you gave it the term number. And it would work for any of these terms up here. So that's A. Let's take a look at and do the same thing for B. So for B, let's just slide this down a little bit. There we go. So for B, we're starting, this is the first term is 20. And then this says, in order to get to the next term in the sequence, you're going to take 1/2 of the current term. So I'm at 20, half of that would be 10, half of that would be 5, half of that would be 2.5, or maybe you just call it 5/2. Half of that would be, to be honest, I would call it 5/4. Half of that would be 5/8. So what I'm doing here is I'm just putting an extra factor of 2 in the denominator each time as I get to these values. So this is geometric, right? Because I have a common ratio here, or a multiplier of 1/2. So every single time it's 1/2 of the previous term, the next term is half of the previous one. Or the next one is, yeah, the next one is half of the previous one. So this one is half of the one that came before it. Now, going forward, of course, I divide by 2, or I multiply by 1/2. I do need to know what the 0th term is to write the explicit rule. So in order to get the 0th term, instead of multiplying by 1/2, I'd multiply by 2. So my 0